If you've got a Bambu Lab 3D printer and it's got an AMS, well, it's technically not a requirement for you to use their filament, but by now you've likely experienced just how convenient it is to use their filament. And you may have even fallen victim to their bulk offers from time to time. Not speaking from experience or anything, but this is a safe place. This video isn't about filament though. It is about convenience, and more specifically, the convenience around all of their hardware selection. Because now that I've acquired a pile of it, and apparently it appreciates me too, we're gonna be using the Carvera Air by Makera. We're gonna pair this up with some interesting ways to use 3D printing alongside the CNC that maybe you haven't seen before. And then we'll move all the way over here to the Monport fiber laser, and we'll probably use this machine for more than you thought it could do. All of this to create what I'm calling my ultimate first order access Bambu Lab hardware collection. In other words, we're going to make a spice drawer for Bambu makers, completely inspired by this anodized piece of metal. I wonder why. One of the first videos that I actually posted to this channel last year was about my hardware collection. It was this one right here. Half expecting to be diagnosed by the internet with different disorders of sorts. To my surprise though, that SteinTrack video got 2.2 million views and over 75,000 likes, and it became the catalyst for starting the Lucky Stein community on Patreon. And that's a group of makers with shared appreciation for flavor. And if you want to try out this flavor of project, a free portion of it does live on Makerworld. But let me say, before you get started with the project, and especially before leaving a spicy comment about fitment, it is absolutely critical that you set your pressure advance correctly for whatever filament you're using when printing the tracks or the Stein ties. Otherwise, things aren't going to fit, and instead of hearing that really satisfying click that you'd seen in the videos, it's going to be more like a crunch, and it will feel as wrong as watching a nozzle sign a build plate, or in my case, watching me write labels on these bins. To be fair, many of those Sharpie comments were actually warranted, and today we fixed that. But also, a lot of you asked, where did I get all of this hardware from? And well, you wouldn't know it from how shiny new it looks in the video, but I've actually been collecting a lot of this stuff since basically high school. And not to age myself, but yeah, that's over 20 years ago. If a project called for 30 machine screws, then the most obvious choice is to buy a box of 500, or in my case, just enough to last until now. Because recently I've had to spend so many hours on AliExpress and Amazon trying to source for these things, but it is crazy expensive these days, and the shipping is also just as expensive. So it's no wonder why people were asking. If you wanted to buy something and get a good deal, you have to buy a whole kit of something, when most times all I want is a 20-year supply of one thing. So I've shifted my sights to efficiency and convenience with what Bambu Lab has been offering, and I order their filament anyways. The hardware ships free with it. And then to further feed my addiction, I even made a menu inside my Stream Deck for Fusion 360. So one button takes me to a page where I can instantly check the availability and sizing and so on right while I'm designing. And honestly, I've actually been really enjoying what they're offering, and the quality has been pretty decent and consistent. And more times than not, it's actually showing up just as fast as Amazon. Now, before you go into my comment section and spice things up, I'm not actually sponsored by Bambu Lab. These are my own views and they're based on my own experience. But Bambu, if you are listening, I will happily take some free stuff. Speaking of free stuff, this pile of hardware here, it's about 250 Canadian dollars worth of just about anything I could ever need in a 3D printing project. And it's thanks to all of your boost on the SteinWipe Makerworld release that this pile didn't actually cost me anything. So thank you, and I dedicate this hardware drawer to all of you. Now, where does this green aluminum card come in? Well, when I designed these bins last year, I actually designed them to incorporate an interchangeable nameplate. And it's just something that you would clip into the top here. You would print it separately alongside of the bin. And if you wanted to, you could easily repurpose the bin later on just by pulling on the sides here, and the plate would drop out. Now, the plan was always to do more than just 3D printing these. I designed this with a product in mind from Trotec, and it was to be cut and engraved on a Trotec laser that we actually have at work. I guess just never made time for that video. Future video? Well, after seeing these cards popping up on my Amazon feed with the correct thickness and in this color, I knew exactly what needed to be done. But how do we go about cutting these out now? And we need to do it with minimum waste because they're not exactly cheap. And just Generally, using a machining strategy presents a lot of challenges with cutting out small parts and clamping. So how do we come up with a strategy that makes it simple enough that I can cut these out, have minimum waste, and set it up on the machine to run these easily in the future with minimum time to set up? Because I have a spicy feeling there's going to be a lot of you requesting a pack of these, and if we're raising the bar on handwritten labels, then I know that doing something like this, well, I wouldn't actually do that with you watching. Now, what I've come up with is this vacuum chuck. Now, this is actually a very simple concept and it works very, very well. And I borrowed this idea from Pearson Work Holding. I've used their equipment in the past. They have specialty vacuum chucks that we use on our Haas milling machines at work. We'll go over it real quick here. At the top, we've got a port, and this port here allows the vacuum to travel through the chamber, and it goes into each of these ports where the part will be held down. We can look at that network just by toggling this on. You notice that I've got these teardrop shape, and this is on purpose to allow the best amount of vacuum seal that we can get, because 3D printers have that issue where once we get that overhang beyond 45 degrees, so if this was a circle and we're trying to close it off, it's going to be doing a lot of bridging in those final layers, and that's probably just going to be a lot of potential for leaks. The vacuum pump that I'm using for this project is a commercial grade deep vacuum pump. It can pump down to 50 microns, which is a very, very deep vacuum. And it's 5 CFM, so it's designed to evacuate large air conditioning systems. Now, getting to the business end here, we're looking at these little pockets where the vacuum will actually take place. So we've got a little spot here, and this is where we would end up having an O-ring. And guys, I just lucked out with this. I have an O-ring kit, and there's 2 O-rings that are this size here. I only had to shrink it by a tiny little bit, so there's a small little bit of compression on this, and I think that's going to work just fine. So this portion that's highlighted here, it is going to be able to produce roughly 5 to 6 pounds of force. So that's force that's pulling straight down into the vacuum chuck itself. Now, we should be able to get a little bit of additional lateral force because we're going to have it compressing against this ring, and that ring should be able to provide a little bit of friction. Plus, the surface here is going to be able to provide some friction. Now, each of these pockets, they're joined together to make a double wide SteinTrack plate. The force will be holding this thing straight down. But the problem is, as you are cutting these blanks away and they fully separate from the rest of the material, probably not enough to actually do any machining operations on them. But if it is all attached, you should be able to machine whatever you want and not have any issues. So the initial operation is going to just cut away the leftover, the excess material here, so that this little chunk sticking out of the side here won't be an issue. And once that finishes, we go into cutting out the parts themselves. We're going to spiral the cutter down into the part, and then the very last pass, as it's going through, that cuts everything away. It's going to do it all in one shot as it breaks through the bottom of the material. That way, this part here that gets cut away, it becomes freed up at the exact moment where it becomes the weakest and has the most potential to be shifted around. So once we go through and we cut this one here, this one, this one, this one, this one, this one, this one, these last 2 here, there's, you know, the combined force holding these 2 would be probably enough, but once it gets to this very last one here, there's not going to be enough force, and I think it's going to shift. I'll probably run it, but while that's printing, I'll head out and get some pneumatic supplies. Pretty convenient that this Princess Auto just opened up about 10 minutes from my house. Used to be across the city, and they have a huge selection of pneumatic fittings. This is great, and they also have this, which I think is going to be fun for a future video. Everything but the service valve and the vacuum hose I was able to get from Princess Auto. I happen to have these things left over from an air conditioning job that I did years ago. So we'll connect all of this stuff up. This nylon vacuum line, you just press it on. It's super easy to work with. I picked up this vacuum pump, the hose, and of course that service valve with the copper stem. This stuff I picked up on Amazon many years ago. I'll leave a link below if you're looking for it. This access point has a valve inside, so I'll remove that for better airflow. And then we can get this thing connected up to our vacuum pump, get it connected up to our vacuum chuck. A little bit backwards here, but while the main chuck is still printing, I created a smaller test version to test the fitment and make sure the threads fit. The first print, I actually forgot to attach the body that had the threads, so I had to print it twice. And then we can test out these O-rings to make sure they fit, and they do fit really nicely. And again, I really lucked out with these. Now, I probably do not need this valve, but I decided to put it in here anyways. Better to have it than to not. And this would allow me to leave the system running. That way I don't have to turn the pump off in between cuts. I can just flip the valve, but it turns out the valve didn't even work anyway. It does have a sweet spot where we can create a vacuum, but I will take it out of the system. And we can see here that we are creating a decent vacuum pretty quickly. Machining this with only 5 pounds of force holding it down is pretty sketchy, but I'm hoping with the drag of these O-rings and a good strategy for machining operations, I'm hoping we can get it done.
Oh, that's not good.
First time I put a screw in it, it's stripped. It's not the screw. Well, hopefully it's good. Well, the last piece of the puzzle just finished printing, and this is a guide, and this will be used to push up against the chuck, and then I can take my plate and then use that guide to put my plate into the correct position, and then I can remove the guide and it won't get in the way for machining. And I've also set up this little locating mark on this guide, and this will be used to set up the work coordinate system. So I'm going to do that now. So we just push this right up against here until it doesn't move anymore. And I'll jog the tool over so that the cutter is right inside that little hole. All right, and I think I got it pretty close. Give the tool a little turn here and you can see. Looks pretty good. Now we go to set origin, and then we're going to say current position, and this will just be for the X and the Y. This is not for the Z. That will be the next step. So that's set now. I've already got my program loaded, so I'm just going to click here to run. And then if I go over to Auto Z Probe, we'll turn that on. And the configure on this is pretty easy. From that point that we just saved, this is going to be spacing at 5 millimeters inwards on the X and 5 millimeters on the Y. So we're going to leave that. And that way we are probing on the inside here instead of trying to probe right on this corner. Uh-oh. Oh, that's a problem. I didn't really anticipate moving the table all the way down here, but obviously that's an issue. I don't think I cut all the way through. All right, so we just remove. Well, I'm on a roll tonight. Okay, remove the cutter and then the probe. And then I've got a little cap on here to keep the debris out of the tool center. I think this will work a little bit better for now. There's a little bit of space back here, and it shouldn't close up too much more because this is pretty much the maximum travel to get to the bottom corner of this. If I find out that this works, then I'll probably drill a hole in the back of the panel and put this little bulkhead connector right here, and that'll get our vacuum inside there and be able to still close the door nicely. Okay, let's try this again. Turn on our pump. And then all we gotta do Just push our guide, push our plate into the guide, and then just, there we go. Got a good vacuum. Now we can take our guide out. And you can see we're about 5 millimeters in. Take the probe out, put in our tool. Oh, we have contact. We're cutting. Well, so far so good. Nothing is sliding. All right, we're coming around the full depth of cut, which is 0.3 of a millimeter. And it seems to be doing it with ease, so I think this is gonna work. Okay, first operation is almost done. It did it! It did it! One down. I can't believe this actually works. Now these last two are the most critical because this is where there's the least amount of force holding these plates down. And then when it's just the last one, hopefully it doesn't fling off. I got my finger on the emergency stop just in case. Oh, I saw it move. I saw it move. It did it! Well, that was a success. 100% the last one did end up moving. So I think what I'll have to do is make sure that I'm just doing 7 out of the 8 and there will just be one that will be waste. I don't want to have any accidents where the piece comes off and then we start sucking in some debris that can end up inside the pump. So what I'll do is I'll just alter the file, that way we're not cutting the last one, so there will be a little bit of scrap. That one will be scrap, but they look great. I don't think there's any issues whatsoever. I'm gonna vacuum this up and turn off the pump, see what they look like. Turn the pump off. And wow, came out really good. Edges are really sharp. Probably should run an edge chamfer, but I'm just worried that there's not enough force holding them down. So you can see this is the last one here. The last one shifted up just a little bit when it came down to this bottom corner. Cut myself on the tool. That didn't take long. Okay, well that actually worked out a lot better than I was expecting, considering I knew going into this that we were going to be pushing the boundaries of physics for what is even possible with work holding, using strictly vacuum to hold these parts down as we machine them. I made some adjustments to the cam file and I did run a few dozen of these and they've all turned out flawless. No tools broken, and that means a huge success. So we are finished up with the Carvera Air, and this video is running on a little bit long, so we will continue with the Monport fiber laser in the next video, and I'll show you some of the neat things that I designed around this machine and 3D printed for the fume extraction. And that video will be right here when it is ready and posted. A big thanks to Makera and to Monport for providing these two incredible machines for projects like this. Discount links for both of these machines are in the video description below. And a big thank you to all of the folks who support this channel on Patreon. The files for everything that you've seen here, including this vacuum chuck, are available on the Lucky Stein Patreon for download. I'll likely create another version of this that is also 3 and 4 units wide for more flexibility with the wider bins, and that will be available soon for all of those who are interested. So keep your eye out for that next video, and until next time, well, happy printing.